So we have the pleasure to have five speakers together with us, mainly from the industry. So we have the session title is CCUS application in Greece. So we're going to discuss about how Energean, Ecolog, Titan Group, Motor Oil and ESFA looks CCUS. So I can give the speech, the floor to Mrs. Sardi. Thank you very much. If you want.
Thank you, Dr. Koukoussas. In principle, I should have a presentation. Do I have a presentation? Okay, I'm starting to walk just to save time. And okay, I do have a presentation. And actually, I could share with you while I start. I was thinking that we refer to this chain as CCUS, whereas in practice it should be like CCSU in the sense that storage would precede the utilization. So it's quite funny that Europe and the world uses CCUS, while utilization, which would mean synthetic fuels, it's far, far to go. Good news is that I see my presentation here. I do not see the presentation there. But, okay. So, just a few words on Energean, although the project has been mentioned a number of times today. Energean has not been mentioned that much. Energean is, for those that you are not familiar with us, we are an independent oil and gas producer with a portfolio of 85% gas, mainly active in the South Mediterranean. Started in Prinos in Greece with some like 3,000 barrels per day, climbed to 50,000 barrels per day, mainly from our FPSO in Israel, climbing now over to 100,000 barrels per day. Aiming to climb up to 200 barrels per day shortly. This is in 2024, if everything goes well. And I'm saying if, because a lot of things have been happening over the last days that have been a shock for us, but also for the world. In parallel, we are developing the CO2 storage in Prinos. Why Prinos? Because it is, as we have been telling to the Commission, Greece included, that this is a very much depleted oil field. At the end of its life, it has been producing oil for 40 years, but oil is actually finishing. It is an area, subsurface, that is very well understood, very well explored. A lot of wells have been drilled there, so it is a known territory. This is very important for the development of a CO2 storage project. And it's also located in the southern part of Europe, where not many projects are around, but it can service the industry of Greece in southern Greece, maybe some loads also in northern Greece, but also service hard to abate emitters, because it is for them actually that the CCS is being developed and not for power, as was the idea maybe 2 decades ago. So service the industry in southern Italy and maybe even Western Balkans or Bulgaria. A lot of you have heard about this project a number of times, so I'm going to be very fast. The good news about this project is that it's being developed on a brownfield. Installations exist. This means offshore installations, platforms that have hosted the oil production for decades. They can be repurposed, originally partly, later in full, to host the CO2 injection wells in an area that has learned to accept industrial activity, very important, particularly for Greece. And it shall be developed in 2 phases. phase one, a small concept to have an operating license by Q4 2025, a very ambitious schedule, and almost impossible schedule if it were not a brownfield, to host small quantities of CO2 that could be transported from projects that are funded by Horizon Europe and also our own acid gas, up to 1 million tons per annum, the original design of the facility, to be expanded up to 3 million tons per annum in a full commercial site that will receive liquid CO2 from various hard-to-abate emitters, from hubs, as we heard from DESFA earlier this morning, or from individual liquefaction facilities. The idea behind is for us as Energean, who have a number of assets across the Mediterranean, to potentially also expand Prinos, because Prinos has a limited storage, and this is the problem with most of these storage facilities, to expand them and take advantage of the experience to be gained so that other storage facilities can be developed in Egypt, Israel, Italy, and beyond. So this could be individual storages or a storage hub. We've seen this map many times. I don't have a lot of things to say, just that clearly we do not need to have, this should not be a Northern Europe development. There's very, very little activity in the south. This needs to be expanded. And how would it be expanded? In the morning session, I missed most of the morning, but I heard some words like let the market operate, have a market competitive value chain. And then later I heard that there is a need for regulation, for regulatory incentives, there's a need for legal incentives, there's a need for the government to support. This is a table that I have shown in a number of other occasions, and the interesting bit with this table is that it summarizes in one part all the tools that were employed for the development of renewable energy sources, where 25 years ago, renewable energy sources, the cost was what we would say today, ridiculous. 15,000 euros per kilowatt, dropping now to less than 1,000 euros per kilowatt. A cost of energy generation at 200 euros per megawatt hour at a time where the cost of electricity was 25 euros per megawatt hour. And then there were tools. The tools were called investment support, grants. There were tax exemptions. There were what was called at the time feed-in premium, originally feed-in tariff, a feed-in premium, what we now call in the CCS chain a CFD contract. It's the same thing. And there were also obligations, quota obligations, like the ones that we begin to see in the Net Zero Industry Act. There were other kind of long-term contracts. And why do you need long-term contracts? Because these investments, like these investments, somebody asked Mr. Vlasopoulos just a few minutes ago, why you are LP, you are the largest company, or at least one of the largest, why don't you invest? But these kind of investments are multi-dollar investments. They cannot be funded by equity. They need to be funded also by loans. No financing institution will grant anything without a long-term commitment. So we have the tools. The governments, the EU, the financial institutions, they know how to do it. They've done it with renewables. They now need to do it again with CCS. Thank you. And this is the project.
Thank you very much, Ms. Sardi. Do you have any question to Ms. Sardi just before? It was very interesting presentation. Do you have any question, or we can leave it for the end probably? There is no question. So can we go to Dr. Panos Deligiannis, Head of Shipping from Ecolog, for your presentation? Thank you very much.
Good afternoon, ladies and gentlemen. My name is Panos Deligiannis. I'm the head of shipping of Ecolog. Thank you, the organizers, for the invitation. Ecolog is a midstream CCUS service provider aspiring to connect emitters to most economic storage safely and effectively. With ships and terminals, of course. And why shipping? Shipping is the integrator. We listen a lot of, requirement for full-scale integration between sink to source to sink. So shipping is an integrator because of the very quick construction, global application, modularity that can allow phasing in of industrial decarbonization, ability to lift any parcel, and allowing resilience both for transportation and storage. Shipping will not require permitting, and it is unlikely that any social perception will affect it. In Ecolog, we have been collaborating with yards, classification societies, makers for effective engineering of CO2 as cargo since 2021, advocating the transborder transportation in the EU since early 22. It is clear that sustainability of industrial decarbonization depends on sustainable deployment of the whole CCUS value chain. The risk of that to happen is a combination of uncertainty. So many people before me, they repeat that, uncertainty and cost. There are four elements for the uncertainty. The carbon price volatility that depends on fundamental factors like interest rates and energy demand, but also depends on the state strategy and hedging. Sudden people going out to buy allowances from the auction, it will increase the price. Lack of funding is the second uncertainty, and that comes from state in the form of tax reduction, ETS. Now EU will give back to states to handle the ETS, so that's a good opportunity. And CFDs, also financial institutions and banks, who they are not going to give any money, any loan, unless they see the support of the state. The inadequacy of legal framework is very important for permitting reasons, for the infrastructure, for the transborder transportation, the ownership and custody transfer, and the very long-term liability. Now, if we go to cost, cost is related to the commercial exposure of every element in the chain. Shipping will be very expensive because of the new design. The high-end containers, cargo tanks, which is almost 50% of the total cost. Emitters, carbon capture systems and machinery, it's very expensive, 2 orders of magnitude of whatever they emit annually. And that becomes even worse for dispersed industry sites. Storage is a quite expensive investment because of the pore space analysis, the purpose screening, all the extra drilling or initial drilling, testing in order to ascertain the magnitude of CO2 injection, and of course this very long liability, sealing liability. On top of everything is the lack of standards. There are no any standards. So everyone needs to pay more in order to have a hybrid and a very complex design in order to cover all options. So based on the design pressure, there are 3 types of liquid CO2 carriers: high pressure, medium pressure, low pressure. High pressure, the cargo is maintained at almost atmospheric temperature and high pressure between 35-45 bar, and it is contained in the numerous small high shell cylinders. Medium pressure, the cargo is maintained around 15 to 20 bar, temperature minus 30 degrees centigrade, and the use of C-type tanks is utilized. Low pressure, below 10 bar, temperature between minus 45 to minus 50 is where it is kept, and density, quite high density of 1.13 tons per cubic meter. In Ecolog, we've concentrated on medium pressure and low pressure in the framework of safety and reliability, and both designs have been assessed to be quite pragmatic, cost-effective, and technology ready. By allocating more than 1,000 man-hours of resources in a series of studies, Hazit and Hazop, we came up with more than 200 hazards and criticalities, which resulted in 132 recommendations. We are quite certain that low pressure, because of the high density, and also because the lower pressure allows the fabrication of much bigger tanks fitted in a much bigger vessel, will offer maximum payload, and this way the scalability and the CO2 cost, the unit cost, is much improved. Ecolog virtual piping platform was introduced in order to optimize terminal and shipping transportation based on main parameters such as the annual capacity, distance, sailing, and speed. The tool utilizes calculators taking into account ship particulars and propulsion, and also includes the PVT tables for the CO2. It will allow the user to choose the degree of resilience required by a given business plan, and the sensitivity analysis of the tool will give an indication of the cost of CO2, of the unit cost, as well as the size of the fleet for a given distance and size of vessel, as well as many other critical parameters that they assist in a more accurate estimation of the unit cost. Trading CO2 at scale comes with challenges because of CO2 unique characteristics. First of all is the triple point, the point where all three phases coexist, is where the point where dry ice will form in the pipes or machinery when flow accelerates and pressure reduces. When that happens, flow will reduce because of clogging of flow passages, and under certain circumstances can even result in structural failure. Purity, the industrial CO2 stream consists of, contains impurities, which are either, or both rather, non-dissolved gases and corrosive substances. The impurities will come from combustion and carbon capture processes, and it will adversely have impact on health, safety, environment. It will change the thermophysical and transport properties, and it will set off reactions, corrosive reactions that can render machinery and containment incapacitated. Pressure, temperature, and density constitute the envelope that dictates the design, the operation, and the maintenance of such system, and also sets up the prerequisites with respect to safety, to pollution, and to commercial exposure. Also poses new requirements for material and complex designs in order to accommodate transportation at scale and the resulted boil-off gas. So, conclusions. Definitely CCUS will play a pivotal role in materializing Paris Agreement. State, Mr. Stefato, state aid will be very important with respect to funding and legal framework, because then that will ensure that the industrial decarbonization will be sustainable. Shipping is decarbonizing enabler that will offer low cost and low uncertainty integration of the full value chain. In Ecolog, we've done a lot of studies looking into the safe and efficient transportation of CO2, of the whole supply chain, and we are very confident that CCUS application will be successful in Greece. So thank you.
Thank you very much. Do we have any question to ask Mr. Deligiannis? I would like, first of all, to tell you that we have already included in the study information about ships and tankers, so there is and CO2 transport based on your information and information from other sources. But it's real something that it's quite new in business, I think. And I think even they are Greek ship owners that they try to use tankers for CO2 transport. They put it in the market nowadays. If that is correct, I don't know.
Yes, that's correct. Yes.
And so, do you think that there is? My question is: do you think that it's a potential market for CO2 for Greece as well? Because, yes, in the world...
Definitely, news come from EU. They are all in for CCUS. It will not play the main role. It will have up to, say, 15-20% of the whole decarbonization, but that's a huge number. It's a number that can only be handled with that what we discussed with the CCUS value chain. So I respect the opinion that aligning all the elements of the value chain, it will be a very difficult thing, and it bears a lot of uncertainty, and this is why no one can put his money on the game unless there is a backup from EU, from state. So, yeah, definitely that would be a main. CCUS will play a main role.
Thank you. Do we have any question from the audience? Yes. Can we give the floor to Mr. Basias? Yeah.
I can hear.
Okay. So first of all, thank you. It is good to have someone from the shipping industry. This is very important because we are talking a lot about the oil and gas and reduction. Okay. It's a three phases question, threefold. First of all, what do you think about the IMO in 2025 and the change of regulations concerning the tax on CO2? Is it something that will be applicable? The industry, the shipping industry will accept that? Not smiling for sure, but this is the first part of my question. The second is, it is related. There are rumors that IMO will try to put a regulation obligation for a reduction of 10% of the speed of the vessels. And I guess you heard about that. And I wonder if this will be accepted also, and how strong or how light, how weak. And the third is how long it will take to establish the capture of CO2 on the vessels. And I'm not talking only about the commercial big vessels, but I'm talking about the yachts also.
Oh, yachts, okay.
Because I know that there are a couple of companies, maybe in Greece also, they are doing a lot of R&D and prepare on that, because in the next maybe decade we will have small equipments on each vessel, whatever the size is.
Well, starting with the first question, IMO and the requirement for taxation. We are used to IMO following EU. So for EU, from next year, shipping will have to pay ETS. So I'm pretty sure that they will find a way, and as we discussed at different levels, there will be a way, possibly as a bunker levy for the emitters to pay for what they emit. The issue of speed reduction, probably you refer to the CII. Actually, there is one more conference beginning of next month discussing CII. And what I was preparing to say is that uncontrolled speed reduction, it will be a disaster for shipping. It will, like I show you here, that visual piping or conveyor for bulkers and tankers.
My question, but I don't want to say that. I'm waiting that you say it.
Yeah, I mean that will increase a fleet that will underperform, because all these vessels, they are modeled and designed to be effective at a certain speed and power level. So if we ask them to reduce, then of course they will burn less bunkers, but that it will not be efficient. And then we multiply, because we don't have enough ships to go around carry the goods. So now about onboard CCS, very quickly. I've seen a lot of companies. We are involved in that. The technology is there. Also, although TRL is quite low, early stage, but I think the most important thing is the infrastructure. Vessel will collect CO2, but then what? They need to offload somewhere, and that will take time to be established. So I see that part of the chain to be the most serious, affecting the whole idea of carbon capture on board. And of course, it will depend on the types, amine or cryogenic carbon capture. There are different ideas, but everything ends up on the question: what am I going to do with the CO2 on board? So,
thank you very much, Mr. Deligiannis. Do you have any other question, please? Yes.
I hope it's just a quick data question. On your chart showing the OPEX dollars per ton of CO2 for your ships, the first question is, why is the gradient going up the longer the journey? And the second is, would you be willing to share the numbers of dollars per ton that should be on the y-axis?
we will see, Alexandros, we will see. But if you remember, slopes are quite different for big vessel. For big vessel, 70K vessel, actually that was a 5 million, 5 MTPA. So for 70, quite big vessel, there is an increase because of the distance, of course, but that is quite small. So if you take the same quantity,
I understand if you're going a longer journey, then it should cost you more money. But
yes, because of the consumption and everything. Yes.
Actually, the gradient goes up after a certain point. It's not for a given ship size. So they're all lower. The gradient goes down the bigger the ship, which makes
exactly
sense.
Yeah.
But for the same ship, it goes up the longer the journey, which
it has to increase. Now, if you're questioning the slope,
yeah,
then this is how it is estimated based on the particular engine power requirements and consumption. With this platform, you can choose between LNG, MGO, so you can have that part of the analysis. And also, I mean, it's funny because if you change the liquefaction rate at the export terminal, or if you optimize the intermediate tanks, then all these curves will go funny. They will change because of you need to estimate how long it will take for the vessel to go and come back. So maybe if it takes long for a given storage to fill up, then you need to employ more units of that given. So it's quite complex modeling that takes into account both export and import terminal. And there's a lot of information. That's why the main is distance and speed, but behind there's a lot of capacity of the terminal itself and turnaround.
Thank you very much. Thank you. Can I ask Mr. Tsikouras from Titan to get the floor for the next speech? Mr. Aristikouras from Decarbonization Strategy Director from Titan. Thank you.
Okay. Thanks so much. Thanks so much for the invitation. Happy to be here. I'll talk a bit about from a different perspective from that of the emitter. I think we've heard quite a bit about storage, we've heard about transportation, we've heard about the authorities looking into this, and I'm going to talk a bit about the perspective of the emitter. Just a quick introduction. Titan Cement is one of the largest cement producers and materials producers in Greece. What we are very proud of is our decarbonization journey and decarbonization targets. We were one of the first cement producers worldwide to have our decarbonization targets validated by the Science Based Targets Initiative. And as you see here, we are moving already pretty fast towards a very ambitious decarbonization pathway. Right? We have set a target of 500 kilograms of CO2 per ton of cement by the end of the decade and going to net zero by 2050. One of the reasons that this is a particularly challenging exercise is the way that cement production works. And cement is a hard-to-abate sector. What this means is that, yes, you can do a lot of things with the energy that you consume. You can use alternative fuels. You can put less clinker into the cement that you produce within standards. But what you cannot address is what we call the process emissions, which are the emissions that are required by the chemical reaction of producing clinker. So whatever you do, however clean your fuel is, you will always produce CO2 as long as you produce cement. So that makes cement one of the hardest to abate industries. It is not like power generation, where you can produce electricity which was produced by fossil fuels by renewables. And therefore, the only way that you can reduce the emissions after a point is through CCS. What we see here is a curve by the Global Cement and Concrete Association, which shows the different decarbonization levers that the cement and concrete industry has. What you see there is that if you go beyond 2030, where you will have exhausted most of the traditional improvement levers, after a point when you want to reach net zero 2050, the biggest lever to reduce that is carbon capture. There is no other way today, there's no other technology today that can achieve that for cement and concrete. And therefore, that makes carbon capture an essential part of the cement of the cement industry going forward, an essential technology and an essential value chain for cement to decarbonize. I also heard one of the previous speakers talking about hydrogen. That could very well work for other industries. At this stage, at least, it is not a technology that has worked for cement. So therefore, the cement industry is one of the biggest things that the cement industry is looking at is carbon capture. We have developed over the past couple of years what we have termed Project Iphistos, which is a large industrial-scale carbon capture project out of our plant in Kamari, north of Athens. This project is a project that includes a full value chain. Basically, the first part that you see on the left of the slide is the carbon. It's an actual capture at the cement plant. The captured CO2 is piped at Elefsina, where it is liquefied, and there's a buffer storage and loading terminal. And from there, it is basically transported by CO2 and stored permanently. The perimeter of our project so far is the first two boxes. So it is the investment that we will undertake is the capture and liquefaction, essentially. We are happy to have been pre-selected by the European Innovation Fund this July as one of the very few projects in terms of carbon capture. That has given us a grant for our project, and it has basically helped us push the development of the project substantially. A couple of things to note. The first is that we are evaluating this value chain and trying to create optionalities. This is not a fixed value chain. We are trying to see optionalities in terms of various aspects of it, in terms of the liquefaction, in terms of the permanent loading, and so on. And we are working with our partners to see how that can work. The second point that I would like to highlight is that if you look at this value chain, it starts from the emitter, and that is not just something that we put on the chart. And I think, you know, most of the emitters that we have been speaking to share that perspective, which is that you cannot bank any part of that value chain without the actual emissions. This is basically a project that each step of the value chain has to make a very big investment. So storage has to make a big investment, shipping has to make a big investment, the hub has to make a big investment, and obviously the capture has to make a big investment, but all this is banked by the capture at the beginning. And therefore, we believe that capture is one of the most important steps in the value chain, in the integrated value chain. Now, I think we've spoken about the benefits of CCS in Greece, so I might be repeating some of what my colleagues had said before. But I think, and this is something that we as a CCS industry and as a CCS value chain in Greece should be explaining to our policymakers more. It is not just about helping achieve the country's net zero targets. It is also about meet growing demand for low carbon products. In our case, it would be low carbon cement or zero carbon cement. It is about creating jobs. It is about creating a competitive advantage for the Greek industry versus industries in our regions which would not have the opportunity to decarbonize. It is about underpinning the economic viability of a strategic project for Greece, which is the Prinos CO2 project, and of attracting significant European Union funding. However, as I think has been discussed very eloquently before, and here I'm certainly repeating what some of my colleagues have said before, this does need support, it does need certain enablers to materialize. And you know, from our point of view, we classify them in three categories. One is in terms of the market. So to what extent do zero carbon products command a premium? Right? We see in some markets and in some countries this happening already. However, via methods like green procurement, the state could certainly help the adoption of these products and therefore help financing the entire value chain. It is about establishing and updating a legal and regulatory framework for the whole value chain. It's about ensuring access to the logistics and storage at fair terms for the emitters. It's about specifying the permitting requirements and any technical and safety standards, but also about defining the appropriate monitoring and controlling authorities. I think there's already quite some progress on that on the storage side, but it's not necessarily the same for the upstream, and I think this would be something that we would very much like to see going forward. And the last thing, again, has been mentioned so far, but we feel that this is an extremely important point, is about de-risking. These are very capital-intensive investments. They are very risky investments. We as emitters run the risk of the ETS price going up and down, and it is very difficult for that risk to be undertaken by any emitter. Therefore, there are methods that have been used in other countries. This is, the carbon contracts for difference was mentioned before. It is one of the tools that has worked in other countries and is being developed very actively and very fast by other countries. So these are things that could certainly help move the value chain forward. Thank you so much.
Thank you very much. Can we ask you, Mr. Tsikouras, can we ask you a few questions? Yeah. Certainly. First of all, I would like to, you said about the Innovation Fund project that Titan got in July. Do you would like to say a few words about what do you know about the technology that we are going to use, and a few words about this project, just one or two words?
Yeah. I think that technology will get probably very technical, so I'm not going to talk too much about the technology. I think the Innovation Fund, and I think a lot of us here are aware of it, is a tool which has been used by the European Union for the past 3 years. The last year was the third round. I think the next round should be opening soon. It's a large-scale grant, effectively, that is given to certain projects which demonstrate both innovation but also maturity in terms of the technologies and the project that they have. It's a highly competitive exercise. Just to give you a sense, out of in the category that we were competing with, there were about 100 projects competing last year. 240, but in the subcategory there was 100 of the large scale, and in that subcategory there were 8 that were selected. They were pre-selected last year. Some of them are continuing the discussion, some are not. But that gives you a bit of a sense of the exercise. We are now in the process of the preparation of the grant agreement, so if all goes well, we should be able to make some more announcements at the end of the year.
Thank you very much. Do we have any other questions to Mr. Tsikouras? No, thank you very much. Can I ask Mr. Daskalakis from Motor Oil to get the floor? Thank you.
All right. Good afternoon, ladies and gentlemen. Very pleased to be here with you and exchange views for CCS, a very innovative and effective technology for the reduction of CO2 from the industry. Actually, Motor Oil started its journey with this technology something like 2.5 years ago as a check, as a interest to see what's going on, and now two and a half years since then, we are ready to start the materialization of our project called ARIS, which is actually give us the tools to radically decarbonize our operations. The whole thing with energy transition came up, became a global issue in Paris, the summit 2015. Actually, and in order to save time, 196 countries decided and pledged that they will try to reduce the energy intensity by 40% by 2050, while at the same time, the energy demand will have increased by 40% in order to accommodate the increase of population by 1.9 billion and the GDP by 130%. So the task, simply written, it corresponds to a huge task and requires a coordinated effort. The thing is that we are not on track. Current pledges are for GHG emission reduction are only 7.5% of what would be by 2030. All in all, CCS has been with us for many years. We have been separating gases from flows for at least 1 century. Carbon capture has been utilized for the last 60 years for enhanced oil recovery by the natural gas industry and the power plants. But now we are called to utilize it in a more effective manner with higher standards and much higher performance rates. As you can see, by 2030, by 2050, it is expected that CCS implemented for hard-to-abate units will correspond to something like 3.4 gigatons per annum. This is the net zero scenario, while at the same time, a lot of importance is given to BECCS, meaning that CCS implemented to bioenergy utilizing units. provided that we have the availability, we have access to the biomass required, which is huge. It's something like 0.9 gigatons to 1.5 gigatons of tons of oil equivalent in bioenergy. Actually, it is 2 to 3 times more what we are using now. Currently, we are, as the other speakers, our previous speakers indicated, we are capturing a modest 40 million tons of CO2. By 2030, we need to reach 1.2 gigatons. We are not there, even if we manage to implement all the planned projects to materialize them. We will be there. We have made it for less than 15% of this target. While at 2050, we need to reach 4.2 gigatons. And the range of estimates expands. Right, when it comes to our project, Project Iris. Project Iris, as explained, gave us the opportunity to serve our main strategic goals and directions. Actually, Project Iris increases our resilience by drastically reducing our GHG emissions by 25%. 25% corresponds to the emissions of just one chimney in our refinery. Actually, our industry has the peculiarity that we are emitting a lot, but we are emitting from many different emitting points. Some of them are big, and we feel comfortable to capture from them, meaning that we have the flows and the concentrations, while others are small, and we cannot do many things in a post-combustion fashion. We defend our sustainability targets as we have set them in our ESG pledges. Motor Oil will become a very big blue hydrogen producer while expanding the capacity to further decarbonizing in these smaller emitting points within the refinery by mixing it in the refinery fuel. Finally, we materialize, and we are quite proud for this, CO2 circularity, as we are ready to install and operate an e-methanol unit. We reduce given the fact that we expect to utilize blue hydrogen and methanol for the transportation sectors, we will drastically reduce our Scope 3 emissions. And finally, the project presents a lot of synergies with existing projects in the refinery and in the surrounding area, meaning that around in the perimeter of our refinery, we have a project for the development of Hydrogen Valley, which will comprise HRSs, technical companies involved in this activity of hydrogen, maritime applications, and so on. However, this was the good part. The difficult part is we are discussing about a multifaceted project. It's about to be constructed in a heavily congested industrial complex. The demands for utilities are very high, are really high, and the OpEx as well. Then we come to the fleet development, which is a question, the operation of the remaining of the chain, and finally, the revenues uncertainty and the development of the relevant markets. We discussed about the markets. CCS is a complete chain. It corresponds to an operating market, and we are called to operate in this uncertain environment. However, Project Iris, as it is now, has been selected in last large-scale innovation fund for funding, and we are in the process of preparing the grant agreement. And we have also initiated the engineering of the project. A quick overview of the project and the way it operates. Actually, it is centered around our steam methane reformer unit. We capture approximately 495 tons of 495,000 tons of CO2 in a post-combustion mode, with a view to preserve the operation of the SMR, meaning that we wouldn't like to intervene with the internals of this delicate unit, and also maintain the high-pressure steam production as well as the hydrogen production. Moreover, we wanted to get out of these streams the largest possible quantity that would give us a hydrogen of the lowest possible footprint, far below the taxonomy threshold, which is 3 tons per ton of hydrogen over the life cycle, meaning including the shipping, the storage, and all the other things. The stream of CO2 is conditioned and compressed, meaning that we remove oxygen, nitrogen, of course, water, and then we compress it. The main part goes for the liquefaction and the temporary storage. We are talking about a big liquefaction plant with a capacity of close to 1,600 tons per day. And then it is directed for these 480,000 tons per year are directed for permanent geological storage. A small proportion of this CO2 that was initially captured is directed to the methanol unit. We are talking about catalytic CO2 hydrogenation, quite innovative and quite demanding. The thing is that we have available green hydrogen from the 30 megawatt electrolyzer that is about to be constructed in the next couple of years. So we have decided to use half of its production for the production of 10,000 tons of methanol. Quite small, but given the fact that the marine market has not developed and has not made their choices yet, given the fact that we need a lot of hydrogen, which is not available, and we need to invest more if we want to go further, we could not take the risk to end up with a stranded asset, both in terms of methanol production and hydrogen production. The methanol production came as an idea, more specifically, when we're discussing about the developments in the marine sector, when we're discussing about circularity in our operations, and when we're discussing about new streams of revenues and new molecules. Methanol is a quite humble molecule, but it constitutes the basis for a large number of both fuels and chemicals of high value. The regulatory framework was pretty favorable at this point when we were made the decision, since the Delegated Act gave us the right to utilize fossil CO2 with green hydrogen to produce low carbon fuels till 2041. This gives us a lot of room in terms of time and experience required to move further with this kind of operations, which actually will put us in the power to X mode of production. Catalytic hydrogenation gains traction with new plants coming online the last 3 years. Albeit its small size, we expect this small unit to give us the opportunity to operate it in a very demanding industrial complex in tandem with the capture unit, because these are interconnected, of course, and also will allow motor oil to test business models, including the usage of CO2 sourced by third parties. Closing this presentation, I would like to once again, note the fact that Project Iris lies and touches upon each and every pillar of our strategy, either be for resilience or either be for sustainable growth. Thank you very much.
Thank you very much. Thank you, Mr. Daskalakis. Very interesting. Can I ask you one thing? How long it takes you the project? I mean, what is the timeline for the innovation? 3 years? Or?
For the Innovation Fund?
Yeah.
It was the second submission. It took us something like 4 months to...
I mean the implementation of the project.
Implementation? As we are now. We expect to finish with the grant agreement to sign it. We need to sign it by mid-December. And then initialize the engineering, which will take us start the engineering 1.5 years to finish with the FEED and have the EPC, and then 2.5 years construction. So we foresee operations by 2028.
Okay, thank you very much. Do you have any question to Mr. Daskalakis? Thank you very much.
Thank you.
Can I ask Ms. Cleopatra Avram then to give us this final speech for this session? From Strategic Planning Senior Manager from DESFA. Thank you, Mrs. Avram.
Hello from my side. I'm last but not least. I hope you're all tired, but I would try to be very quick and address just one question that also Mr. Dimas mentioned before. Where do we see DESFA stepping in this whole value chain? So let's summarize a little bit. As DESFA, we see that the whole value chain can be split in 3 main parts. Mainly we refer to the capture, the transportation, and the storage. I think you'll understand where DESFA comes in. Of course, the transportation. Transportation of gases is DESFA's DNA, let's say. We have been doing that for many years. So we would like to play a vital role in this part. And what do we refer by transportation? We refer that we will get CO2 from the fence of the emitter. We will transport it through pipeline, liquefy it, and then forward it for permanent sequestration. Somehow, we're in the middle of what previous speakers have already addressed. We have done our homework a couple of years ago. Many things have been already mentioned about hubs. We see and we have classified that there are in Greece 3 main clusters. We refer to the Attica region, to south part of central Greece, and to Thessaloniki district. Of course, we have started from Attica region, which needs to be prioritized, as the larger emitters are positioned in this area. So what we have done last year and pretty much concludes by the end of the year, we have finalized the structure of the midstream part of this whole value chain. We have addressed it along with Energean as a whole project in the European Commission under the name Prinos CO2. The project will be eligible in the 6 PCI list, is eligible in the PCI list, and will be also included and will be a candidate for further grants. We refer to a project, the part of DESFA, of 500 million, including the transportation through pipes and the liquefaction part. It's a project that needs to run fast. We have seen there are many other stakeholders, cement refineries, that we will try to be part of this, of their projects and collaborate with them closely. And that's all from my side. I would like to thank again once more INE for inviting us here, and I'm happy to address any question.
Thank you very much, Ms. Avram. Thank you very much for being quick for the presentation. We are all tired. Do we have any question to Ms. Abram? Clear. Thank you. Thank you very much. So I think we finalize everything with the session 4. I cannot see Mr. Stambolis here, so probably he wants to give some closing remarks. He's outside, yeah. Okay, so from my side, I don't have anything else to say. Thank you very much for coming, and it was our. We're very happy to be all of you here together. Thank you very much.